On the Mercury 2 flight, Ham is a stand-in for the astronaut. He arrives on the scene in the same van that will be used by the astronaut. The form-fitting couch is like the one that the astronaut will use. The first United States astronaut will take the same van out to the same launch pad and up the same elevator to the top of the rocket and into the Mercury spacecraft, just as Ham is doing on this day. The astronaut will go through this same kind of dress rehearsal. About the only difference is that the first astronaut will climb aboard the spacecraft in his own pressurized suit and into a couch previously installed for him. The spacecraft in which the first astronaut will ride is almost identical to this one. The environmental control system is the same, and the automatic altitude control system is identical. Ham's dress rehearsal is perfect, and the launch is set. Tanks of liquid oxygen arrive and fueling begins. The Redstone rocket burns a mixture of alcohol and liquid oxygen. Throughout the night, the countdown continues, and in the pre-dawn hours, Ham arrives at the gantry. This time, it's for real. At dawn, the recovery ships are on station, and at Cape Canaveral, Mercury 2 with Ham aboard is ready. The medical monitor shows that Ham is resting quietly, his heartbeat steady, respiration normal. Now it's time to pull the gantry back. Mercury 2 nears launch time. In the control room, the flight director presides over the countdown. Liftoff, and Ham is on his way. In the control center, the flight surgeon's eyes are glued to his console, monitoring Ham's condition. Concern mounts. Ham's heartbeat and respiration climbs fast. Mercury 2 now leaves a visible trail and it's flying higher and faster than it should. But with the abort system operative, the Mercury craft begins to behave exactly as programmed. The Mercury craft landed further downrange than programmed. Eventually, the ship rendezvous with the capsule and rescues the passenger. Wave action during the recovery phase has torn off the impact bag. The moment is tense, and the crew gathers to witness what is hopefully the safe delivery of Ham. This hero chimp was, however, fine, and the MR2 was successful. Test objectives were achieved. Mercury systems worked in space. A man could have made the trip into space and back safely. Mercury 2 was a significant milestone on the highway to manned flights into space. UFOs, unidentified flying objects, have been a feature of American life since a man named Kenneth Arnold says he saw 9. Millions of people believe. Others think it's ridiculous. On the night of October 24, 1968, at Minnow Air Force Base in North Dakota, Airman First Class Mike O'Connor was dispatched to make a routine repair at one of the missile sites. He said out of the corner of his eye, he observed what he thought was a farmer's yard light. As he proceeded down the road, the object appeared to lift off the ground and parallel them down the road until they came to the missile site. The Minnow Control Tower diverted a B-52 to investigate. The navigator on the B-52, Captain Patrick Maskelyne, suddenly identified an object on his radar screen. These pictures of the radar screen show the object flying in formation with the B-52. Captain Brad Runyon was the first to spot what appeared to be a glowing craft hovering near the ground. The animation you see here is derived from witnesses who said that this is exactly what they saw. From 1947 until 1969, the US Air Force said it was actively investigating UFOs, calling it Project Blue Book. According to Blue Book's investigation, the crew of the B-52 and 16 witnesses on the ground said they saw a UFO that night. In its final report, Blue Book concluded they were all seeing stars. The year is 2005, a big year for the space industry. On January 14, the European Satellite Agency's Huygens probe landed on Titan and delivered the first ever direct sampling of Titan's atmospheric chemistry. And the first photographs of its mysterious surface. In the field of launcher technology, European engineers have spared no effort to get the Ariane 5 10 tons launcher program back on track. The Vulcain 2 engine's cooling system was improved and the thermal coating altered. A number of test firings in Fernan, France showed satisfactory results. On April 15, the Italian astronaut Roberto Vittori was the first European to lift off for a second mission to the International Space Station. The main objectives for the Marco Polo mission were to change the Soyuz rocket attached to the International Space Station, the so-called lifeboat, and oversee the changeover of the ISS Expedition 10 crew for the 11 crew. Vittori also performed a full experimental program with significant Italian participation during his stay in the ISS. Also in 2005, the flight of the ESA's first automated transfer vehicle. The ATV is named the Jules Verne, after the French writer who died over 100 years ago. This unmanned freight carrier, launched on top of Ariane 5, was able to dock to the International Space Station all by itself. Once the 7.5 tons of payload were unloaded, the ATV serves as a gigantic space trash can. Another important role for the ATV is boosting the altitude of the International Space Station, compensating for the drag of the Earth. Meteorologists benefited from the launch of the Meteosat second generation. This sophisticated weather satellite carries a 12-channel radiometer that allows regional and highly specific weather predictions and generates a new image every 15 minutes. MSG-2 was placed in a parking orbit until needed to take over MSG-1's duties, ensuring continuity. Around the same time, CryoSat took off into space to monitor the ice sheets of the poles. CryoSat will also measure the thickness of sea ice with unprecedented accuracy and register the changes of the ice in relation to global warming. Soon, scientists will be able to tell with certainty whether the North and South polar ice sheets are melting, and if so, how fast. Throughout 2005, both Smart 1 and Mars Express sent data to Earth on a regular basis. During its mission to the Moon, Smart 1 successfully tested new means of propulsion using solar energy to travel to other planets. ESI launched its first mission to Venus, called Venus Express. After a 5-month interplanetary cruise, engineers injected the spacecraft into a 24-hour Venusian orbit.
They're looking at ejecting before the temperature reached what they felt was critical landing.
Also in 2005, Europe took a huge leap forward in the field of navigation services. A first technology demonstrator satellite was launched in preparation for Galileo, Europe's own satellite navigation system. By 2008, the entire system and its 30 satellites should be operational. Galileo will be interoperable with the American GPS system and will allow position fixes accurate to 1 meter. From a political point of view, 2005 was of prime importance for Europe's space agency. The first ever Space Council was an important step towards formulation of a European space policy. Decisions on new space programs will affect Europe's future in space. These are likely to include global Earth observation, telecommunications, and the exploration of planets, both manned and by robots. When fire, poisonous fumes, and molten rock come pouring out of the ground, it's spectacular, but also deadly. It's the same when summer wildfires rage through parts of Europe or elsewhere. To combat these catastrophes, information is essential. Discovering the size of a disaster means the best way can be found to fight it. That's where the International Space and Major Disasters Charter comes in. With a catastrophe threatening, as for example with these wildfires in Portugal, the local civil authorities send a fax calling for help under the Charter. The fax arrives in Frascati near Rome, where the European Space Agency has centralized its operations for observations from space. First, there's a check to make sure the fax has come from someone who is authorized to ask for their help. This charter has been invoked more than 70 times since October 2000, when it was first organized by ESA and the space agencies of France and Canada. It now includes the US, India, Argentina, and Japan, and the UN is an important cooperating body. Once the operating checks have been completed, the fax is passed on to the emergency on-call officer. On this occasion, it's Simone Paolini. He immediately checks which satellites would be able to track the progress of the fires in Portugal. The Spot orbiter can see the ground only in the right weather conditions, but radar satellites like ERS-2 have special sensors which mean they can operate all the time. Reacting swiftly to requests for help is important. The most advanced satellite, envirosat, has 10 separate, different onboard sensors, which makes it one of the most effective for the European Space Agency in the kind of work carried out under the International Space and Major Disasters Charter. The information that's received is processed to make it most helpful to whoever originally asked for assistance under the Charter. Oil pollution from shipwrecked oil tankers is one area where it is particularly effective. Thanks to satellite images tracking the spillages in real time, anti-pollution measures can be put in place quickly. The system works well with other types of natural disasters as well, and the new generations of satellites provide data regardless of such factors as clouds and smoke. That means they can quickly give precise information on the state of roads and buildings after an earthquake, even in the most isolated locations. This is essential in order to know the best ways to send in help. At the satellite monitoring offices in Frascati, activation of the charter also gives access to extensive archives. This enables them to make exact comparisons with the previous images from the satellites. The archives, which go back to 1991, contain all the information that the observation satellites of the ESA have gathered. They are kept to allow comparisons of places before and after a disaster. Overall, the system works well, but it could be better. Man's fragility in the face of forces of nature is undeniable, but at least this way, we are making progress with being able to reduce the effects of major catastrophes. From the cameras of the Space Shuttle Atlantis, the distinction between two different environments is apparent. All-encompassing is the infinite mass of space, a vacuum in which humans cannot survive without complicated life support systems. And below is the planet Earth, home of abundant life and the human species. Changes over the years, such as ozone depletion and the greenhouse effect, have been detected and recorded by scientists. These are the result of changes taking place in our atmosphere. The ozone is made up of oxygen. However, a regular oxygen molecule is made up of oxygen atoms that are bonded together, whereas ozone molecules comprise of 3 oxygen atoms bonded together. In a laboratory, it is possible to construct ozone so that its characteristics can be studied. It can also be made naturally in the upper atmosphere. In its natural form, the ultraviolet from the sun breaks apart the bond in molecular oxygen to form 2 separate atoms. Ozone is formed when these atoms join with other molecules. Scientists believe that if ozone did not exist, cases of skin cancer and eye cataracts would dramatically increase. Thus, its importance is demonstrated. Sunscreen would serve as a level of protection for humans, but animals are still unprotected. Scientific instruments carried in weather balloons, satellites, and sounding rockets are showing that ozone levels are decreasing over much of the Earth. In Antarctica, ozone levels decrease annually from September to November. The main causes for these dropping levels are the use of chemical compounds, CFCs, and the many different oxides of nitrogen. These compounds are broken down in the upper atmosphere into smaller parts. The CFCs give off chlorine atoms, whereas the nitrogen oxides turn into nitric oxide. These are then joined by other chemicals containing hydrogen, sulfur, and other such atoms. A reaction occurs when these chemicals encounter ozone that breaks away from an atom of oxygen from an ozone molecule. The product of these individual reactions also affect other ozone molecules. Thus, one reaction can spawn off a chain reaction that destroys many ozone molecules. These chemicals come from sources like methane, formed by agricultural activity, the cattle industry, and decaying vegetation in swamps. Nitrogen is released into the atmosphere during lightning storms. Chemical fertilizers that we spray on crops are often nitrogen-based and result in increased release of nitric oxide into the atmosphere. When carbon dioxide blankets the Earth and traps heat, it is called the greenhouse effect. In a greenhouse, radiation from the sun passes through the translucent roofing completely unhindered, yet the heat emanated from the Earth is trapped by the glass. The temperature within the greenhouse rises due to this trapped heat. This is exactly what happens on a larger scale to the Earth and results in global temperatures rising as carbon dioxide in the atmosphere increases. Volcanoes can cause excess levels of carbon dioxide, along with forest fires and many human activities. Millions of tons of carbon dioxide have been pumped into the atmosphere from over 100 years of fossil fuel consuming machine use. Vegetation cover is also being reduced by forest harvesting and land clearing. This affects the atmosphere adversely as vegetation limits increases in carbon dioxide. The atmosphere is being continually monitored by scientists to determine the presence of gases and trace elements. Ultraviolet radiation from the sun is also being measured. These studies are aimed at better understanding how chemicals in the atmosphere react with the sun's energy levels, and how in turn that affects our environment. Mankind has been launching satellites into Earth's orbit for over 50 years. Thousands of these man-made objects are orbiting the Earth, and most will stay there for decades. Only a few are still in use. The rest are space junk. The problem of space debris is the result of a lack of awareness during earlier phases of space exploration. In the 1980s, several hundred satellites were put into orbit each year, mostly as spy satellites. Each mission meant more junk stayed in orbit, such as the upper stages of rockets. There's even the outer glove from a spacesuit, lost by astronaut Edward White during the first American spacewalk. Space debris, or micrometeorites, sometimes crash into old fuel tanks or batteries orbiting Earth. This can cause explosions, creating clouds of new space debris with innumerable tiny bits and pieces. Since the beginning of the space age, there have been almost 200 explosions in orbit, many involving old rocket bodies. Because space debris is traveling so fast, even small pieces can cause big damage. Space debris is not only an aesthetical or environmental problem. If the debris increases further, there is danger that further space exploration could suffer. Protecting future missions from high-speed junk is being taken seriously. The European Space Agency has hosted a conference in Germany on this issue. Hundreds of leading space scientists attended to discuss the scale of the problem and what can be done to keep Earth's orbit safe for spacecraft.